Prove that, in a right triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. So what we're trying to do in this question is actually prove Pythagoras' theorem. So how are we going to do that? Well, the first thing I'm going to do is draw a little sketch to help us. So the first thing I've done is I've actually sketched a right triangle. So we know it's a right triangle because we've got our right angle. Okay, so this isn't going to be much use on its own. So I'm going to draw another line to help us. So the line I've actually drawn is a line that is perpendicular to AC, and it goes up from a new point we call D to B, and we've actually got now a right angle at D as well. So what we're going to do first is actually consider two triangles. So we've got triangle ABD and triangle ABC. Well, the first thing that we notice between our two triangles is that angle ADB is equal to angle ABC. And that's because both of these angles are actually in fact 90 degrees. Okay, so that's one angle we know that's going to be equal. Do we know about any other angles that will be equal between our two triangles? Well, we also know that angle BAD is going to be equal to angle BAC, and this is because they're actually in fact the same angle, because it's common to both of our triangles. And then therefore, the third angle of each of our triangles must also be equal, so we can say that angle ABD is equal to angle ACB, because the other two angles are equal. And therefore we can say that triangle ABD and triangle ABC must be similar, and that's because all of the angles are the same. Now, because our triangles are actually similar, we know that therefore, as they're similar, the corresponding sides must be proportional. So what we can say is that AD over AB is equal to AB over AC. That's because AB and AC are both of our hypotenuses, and then we can see that AD and AB therefore must also be corresponding. Well, if we actually multiply each side of our equation by AC, we're going to get AD multiplied by AC over AB is equal to AB. And then next, if we actually multiply both sides of the equation by AB, we're actually going to get AD multiplied by AC is equal to AB squared. So great, what we've actually done here is found out the square on the side AB. So now what's the next step? So now what we're going to do is actually consider triangle BDC and triangle ABC. So again, first of all, we've got two angles that are both 90 degrees. So we can say that angle BDC is equal to angle ABC. And this is because we actually know that the line BD is perpendicular to the line AC. So we know then that angle BDC is also going to be 90 degrees. So now we've actually got an angle that's common to both triangles like in the first triangle. So we've got angle at C, which means that angle BCD is equal to angle ACB. As we said, and that's because the angle there is common to both triangles. And then, yet again, the third angle must also be equal in each triangle, and that's because angle DBC is equal to angle BAC, and that's because the other two angles are equal, so hence the third angle must also be equal. So therefore we can say that triangles BDC and ABC must be similar, and that's because all the angles are the same. So again, as we've got two similar triangles, then corresponding sides must be in proportion. So we can say that DC over BC is equal to BC over AC. So then what we're going to do is actually multiply each side of the equation by BC and AC, and this is to get rid of our fractions. So therefore, we're going to get DC multiplied by AC is equal to BC squared. So now what we've got is actually two equations. The first equation is the square of one of the shorter sides, so AB, and we know that AB squared is equal to AD multiplied by AC. And then what we've got is the second equation is actually the square of the other shorter side, because we've got DC multiplied by AC is equal to BC squared. So then if we look back at the question, what we want to see and what we want to prove is that in a right triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. So we've got actually the squares of the other two sides here, so let's add them together, because that will give us the sum of the squares. So therefore when we add them, we're going to get AB squared plus BC squared is equal to AD multiplied by AC plus DC multiplied by AC. And on inspection, what we notice is that actually on the right hand side of our equation we have a shared factor, and that is AC, because there's an AC multiplied by AD and there's an AC multiplied by DC. So in that case, we're going to take this out as a factor. So therefore, when we do that, we get AB squared plus BC squared is equal to AC multiplied by AD plus DC. Well, if we take a look back at the diagram, we can see that AD plus DC is going to be equal to AC because it's the length AC that the AD and DC make up. So therefore, we can say that AB squared plus BC squared is equal to AC squared, and that's because we substituted in AC for our AD plus DC, and then we've got AC multiplied by AC, which gives us AC squared. Well, as AC is the hypotenuse, then hence we've actually proved that in a right triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides.